Hello, chemical systems. So today we're going to do an experiment on the solubility of salt. So before I get into that, let me kind of review a few things. So yesterday, you guys learned about solutes, solutions, and solvents, which I'll review again in just a little bit. But I just wanted to make sure that you guys understand the distinction between a solution and a mixture with chemistry. So a solution is something where something is completely dissolved. When it's completely dissolved, it's almost like it's not there. It is there, but on the left of here's my example here. My homogeneous solution, my coffee, is actually transparent. So the coffee and maybe even some of the sugar you put in there would completely dissolve in there, which means there's no grains of sugar or no grains of coffee left. Whereas a mixture would be something like a bowl of cereal. The cereal flakes don't really dissolve into that milk, and actually the milk itself isn't a proper solution. So that's kind of just a really brief overview of solution and a mixture. And so since we're looking at today the solubility of salt, let me show you why something actually dissolves like this, like your coffee would in a cup of coffee. So this is a simulation that you guys will have available today. This is a simulation of what happens to salt in water. So here I have a cube of salt. In my experiment today, I'm not gonna have a cube of salt, but here's some salt. Here's all the water molecules. I'm gonna start the simulation. What happens is that water molecules have a slight charge to them. Since they have a slight charge to them, they can capture these ionic molecules. Remember, ionic bonds are made when two atoms have their own charges. So they grab onto these salt molecules and they just kind of take them and float around, which is why we don't really see grains of salt whenever we dissolve salt into water. We just kind of see them because the water molecules are kind of grabbing them and taking them around, and they're too small for us to feel or see anymore. So this is a simulation. This is what's actually going on when we dissolve things in water. Now let's actually look at the real thing. All right, so like I said, in my experiment, I am mixing salt into water. So in this case, salt is called my solvent, is what I'm dissolving. My solute is what I'm dissolving it into. So only when I put the two together do I make a solution. So I've already measured out some salt. If you guys look at the tables on CK12 today, it says that the solubility constant for table salt, which is what this is 180 grams per half a liter. And so I did some math, and that means I should be able to dissolve. I only have 200 milliliters here. Half a liter would be 500 milliliters. I don't want to use too much salt though. What that is saying is that for every 500 milliliters of water I have, I should be able to dissolve 180 grams. Like I said, I don't want to use that much salt, so with 200, I should be able to dissolve 72 grams. And I forgot to get a mixing spoon, so I'm just going to improvise here. So when I get past that many grams, so I should be able to do 12 scoops of salt, 12 teaspoons of salt. And after 12 teaspoons, I should be able to see that there's going to be some salt settling at the bottom. So let's test it out. So here's one. I'm going to put a few in there. And then just mix it up. 2, 3. And you see it's getting cloudy. So I should be able to dissolve this. I just keep mixing. So it's cloudy, but I can't see the individual grains of salt, which means that they are dissolving. Okay, so that's 3 scoops, or 3 teaspoons. So I should be able to get 9 more. Let's see. 4, 5, 6, 7, 8. Nine. Yes, I'm making a mess. Kind of in a hurry because I only have 5 minutes left on this video. You know I'm gonna need some more salt here. It's still dissolving. So of course you wouldn't really make this much salt water normally. If you add salt to your cooking, you don't really add this much salt. Just so you'll be able to do 3 more scoops. 3 more teaspoons. Keep saying scoops. 3. Okay, so now I should have the maximum amount of salt dissolved in here. And actually, I'm already seeing some individual grains. I was hoping to be a little easier to see on the camera, but you guys might not be able to see individual grains of salt with my little webcam here. So actually, I scooped some out, and you can see that there are some salt grains in there. What I'm going to do now is I'm going to pause the video, and I'm actually going to heat this up. So, well, actually, before I do that, let me just go ahead and say something. So what I have here is a saturated solution. When I say it's saturated, that means the water cannot take on any more salt. In fact, I think I added more salt than the water can take on. If you remember that simulation I showed you of those water molecules attaching themselves to the salt molecules, well now, basically, all the water molecules are holding on to salt molecules. There's no more water to hold on to any more salt. So water can only take on so much solute before it runs out and it can't dissolve anymore. And there's like a big pool or a big chunk of salt kind of gathered at the bottom of the beaker here. What I'm going to do is I'm going to heat this up. I have a hot plate over here. And I'm going to show you that you can actually change the solubility constant depending on the temperature. So if I raise the temperature of this water, this will actually allow me to add more salt. And so I'm going to show you that in just 1 second. All right, so I've had this on the burner for just a little bit, and you can see that the water is starting to clear up, which means that the water is actually taking in more salt. What I'm attempting to make is what's called a supersaturated solution. So if something's supersaturated, that means at normal room temperature, it could not dissolve this much salt, but since it's heating up, it can dissolve more. And we do this all the time when we're cooking at home. We have our we boil water so it can easily dissolve something. In fact, the warmer the water is, the quicker it can dissolve something. So I'm gonna let this boil, and hopefully all of this salt will dissolve at the bottom. I'll make a supersaturated solution, and then I'm gonna tell you what I'm gonna do with it at the end of the video. All right, so I've let this go on for a little while. I think that this water even though it's boiling, has dissolved as much salt as it's going to dissolve. So here's my supersaturated solution. I obviously started with more salt than I thought I needed. So I did my measurements, my math. I did something wrong. Anyway, but I can tell that this is dissolving more salt. There's more salt dissolved in the hot water than there is the room temperature water. The reason I think supersaturated solutions are cool, in other words, remember, this has more salt than it can normally dissolve at room temperature, is that when I cool this down, it can actually form salt crystals. And so I'm gonna let this cool down. Hopefully some crystals will form in this water. I'm just gonna let it cool down at room temperature, let it cool down really slowly, and see if I can get some crystals to form. And I'll post a picture on Google Classroom. So thanks for watching. Take it easy.